Welcome to Daily Papers, the podcast where we break down one interesting research paper every day. Today's question: we all know AI is getting better and better, but is there a predictable rule for how much it actually helps us at our jobs?
It's a great question. We hear about a new AI model and it feels like magic. But how do you measure that magic in terms of dollars and cents or hours saved? A new paper from Yale University tries to do just that. It's called Scaling Laws for Economic Productivity by Merali.
Scaling laws. That sounds very official. What does it mean?
In the world of AI, a scaling law is a predictable relationship that says if you increase the ingredients, like the amount of computer power or data you use to train an AI, you will get a predictable improvement in the AI's performance. This paper asks, can we create a similar scaling law for economic productivity?
So, like a formula that says for every dollar we spend making AI better, we get X amount of productivity back in the real world.
Exactly. And to figure this out, the researcher ran a huge experiment. They recruited over 500 professionals, real-world consultants, data analysts, and managers, and gave them tasks to do that were just like their day jobs.
What kind of tasks are we talking about?
Things like writing a strategic report, analyzing some data to test a hypothesis, or creating a project plan. Some of these professionals were in a control group, so they had no AI help at all. The others were randomly given access to one of 13 different large language models, or LLMs.
So some people might have gotten an older, less powerful AI, and others got the latest and greatest model.
Precisely. And to make sure everyone was trying their best, there were big incentives. The base pay for a task was $15, but if your work was graded as high quality by an expert, you got a bonus $15, doubling your pay. So this measured both speed and quality.
Okay, so the experiment is set up. First things first, did having any AI help at all compared to the people with no AI?
Oh, it helped a lot. It wasn't even close. The researchers came up with a metric called total earnings per minute, which combines how fast people worked with the quality bonuses they earned. Access to any AI, even an older one, increased people's total earnings per minute by a staggering 146%.
Wow, so they were basically earning money nearly 2.5 times faster. How did that break down between speed and quality?
It was almost a perfect 50-50 split. About half of that massive gain came from people completing their tasks much faster, and the other half came from them producing higher quality work that was more likely to earn that bonus payment. So it wasn't just faster, sloppier work. It was faster and better.
That's a huge win for AI. But the main point of the paper was about scaling, right? Did the newer, better AI models give a bigger boost than the older ones?
They did, and in a surprisingly predictable way. This is the first economic scaling law they found. For each year of progress in AI models, the time it took for a professional to complete their task was reduced by about 8%.
An 8% productivity gain every single year, like clockwork. That's a powerful compounding effect. Do we know where that improvement comes from? Is it just that the AI companies are using bigger computers?
The paper actually breaks that down. They found that about 56% of the improvement comes from what they call compute scaling, which is exactly that, just throwing more raw computing power at training the models. The other 44% comes from algorithmic progress, smarter training techniques, better data, and more clever software.
So it's a mix of a bigger engine and better engineering. But I have to ask, does this apply to all kinds of work? Is AI equally good at helping me write an email as it is at, say, managing a complex project in a spreadsheet?
That's a key question, and the answer is no. The gains were not uniform. The biggest boosts were for what the paper calls non-agentic tasks. Think of these as analytical or creative tasks that happen inside one window, like summarizing a document or analyzing data.
Okay, so thinking and writing tasks. What are agentic tasks?
Agentic tasks are ones that require multiple steps and the use of external tools. For example, a task that requires you to extract data from a PDF, open a spreadsheet program, create a Gantt chart, and then email it to someone. For those tasks, the productivity gain from AI was much, much smaller. It seems current AI is a fantastic co-pilot for thinking, but less helpful when it comes to actually doing multi-step procedural work.
That makes sense, but the paper has one more fascinating and, frankly, slightly worrying twist, especially when it comes to the quality of our work.
It really does. This might be the most interesting finding. The researchers decided to test the AIs on their own without a human in the loop. They had the AIs complete the tasks, and the experts graded them, and they found a clear scaling law for quality. The more powerful the AI model, the higher the quality of its work. The best models were producing superhuman output.
Okay, so better AI means better quality work. That sounds logical. Where's the twist?
The twist comes when you put a human back in the picture. When they looked at the final work submitted by the humans assisted by AI, the scaling law for quality completely vanished. The final submission was flat. It didn't matter if the person was using a basic 2-year-old AI or a cutting-edge superhuman AI. The final quality score was the same.
Wait, how is that possible? If the AI gives you a better starting draft, shouldn't your final product be better?
You'd think so, but it seems we humans are the bottleneck. The paper suggests we all have some sort of good enough standard. When a weak AI gives us a mediocre draft, we work hard to improve it and bring it up to that standard. But when a superhuman AI gives us a brilliant draft that's better than our standard, we can't help but tinker with it, and in the process, we actually make it worse, dragging it back down to our own good enough level.
So we're actively degrading the high-quality work of the best AIs. We're the bug in the system?
In a way, yes. The incredible value in quality being generated by the most advanced models is being lost in the last mile of human interaction. We're regressing to our own mean.
That is wild. So putting it all together, what does this mean for the economy as a whole?
Well, the authors use these scaling laws to make a big prediction. Factoring in this predictable 8% annual improvement in speed, they estimate that AI could boost U.S. productivity by approximately 20% over the next decade. That's a much higher number than previous studies have found, precisely because this paper accounts for the compounding, predictable improvement of AI.
A massive potential boost to the economy with a fascinating psychological insight that we humans might be actually getting in the way of even bigger gains in quality.
Exactly. The paper shows that AI's economic impact isn't just a one-off boost. It's a dynamic, accelerating force, and understanding how we work with it and when to just get out of its way is going to be the next big challenge.